Welcome to Brain Vision.
We have these two discs and they're attached to each other by a tape. So this tape down here has a tension of 0.75. There's some tension here of TAB. There's some tension up here of TB. So we need to find TAB and TB. We're told that the weight of the top disc, I don't know why they gave us the weight and not the mass, because this just requires a silly conversion that takes up time. We're going to divide this by 32.2 and we're going to get a mass of 0.043 pounds second squared per foot. And then we're going to do the same thing for B, and we're going to get M of B is 0.1087 pounds second squared per foot. So we're going to divide this by 12 to get this in feet. That will give us 0.0625 feet. We will get 0.1087.42 feet. Here we're going to get 0.125 feet, and here we will get 0.075 feet. So the first thing we're going to do is we're going to find the sum of moments about A. So we have an initial angular momentum of 0. Then we have a moment that is created by the tension force AB, which we're going to call the positive direction. So we have RATAB times T. That's the impulse created by the tension force AB. Now we have the impulse created by the tension force A. So this is minus RA, since it's in the opposite direction, TA, T. And this is all equal to the moment of inertia of A times omega A. And this, of course, is equal to MA times the centroidal radius of gyration of A squared. So now we have to solve for, let's just plug in our values, and we're going to be solving for TABT. And keep in mind, all we're doing here is the impulse momentum theorem. This is the impulse, and this is the change in momentum. So we have an RA of 0.075 times TABT minus 0.075 times TA, which is, 0.075 times T, which is 2.54, equal to MAKA squared. So that is going to be 0.043 times Ka squared, which is 0.0625 squared, times omega A, which is, oh yeah, we haven't calculated that yet. So omega A is going to be equal to V over RA. So that's going to be 10 feet, since the V at 2.54 seconds is 10, so it's 10 divided by, what did we say RA was? 0.075. So this gives us, what does it give us? $133.33 seconds. No, radians per second. Okay, so omega b can be found using the same process. It's going to be v, which is 10, divided by rb, which is 0.125. So that gives us an omega b of 80 radians per second. So this is down here, we have an omega a of 133.3 radians per second. So we're going to solve that, and it's going to end up giving us a TAB times T equal to 0.4785. So to solve for TAB, we're going to divide that by the time interval, which is 0.254, and that should give us 1.99 newton pounds. So that's the answer to part B. Now let's look at the moments around A. Moments about A, or B, sorry. Moments about B. So this one also starts from an angular velocity of 0. So it has an angular momentum of 0 to begin with. It has an impulse created by the tension force TBT at a distance RB. We have RB times TAB ABT, because this tape is also creating a tension in the opposite direction. And so we have, this is all equal to mb kb squared times omega b. So this is going to give us, we plug in all our values. We can plug this in for TABT. So we're going to get 0.125 TBT minus, and this is going to be times 2.54 minus RB, which is 1.5 times TAB, which is 0.4785, times T, which is 2.54, is equal to MB KB squared. So MB is 0.1087, KB is 0.1042 squared, and omega b is 80 radians per second. So if we solve that for TB, we are going to end up getting 5.15 pounds.